Unified Compaction Strategy has this thing called scaling parameters. Okay, scaling parameters affect the way that the data is tiered out on disk. Okay, so if you have a scaling parameter that starts with an L, that means it's going to behave like leveled. So that means there's a whole bunch of data in the level, and that gets compacted together, and then eventually it gets merged into the higher level. When you have size tiered, the way that it works is it takes SS tables that are similar in size and it compacts them together, and then you end up with bigger ones. The problem with size tiered is that you end up with really huge SS tables after a while. I've actually worked back when I was at TLP. I worked with a team that had SS tables that were they were close to a terabyte. So it was like they would just sit there. And the big problem with size tiered when it gets like that is when you have an SS table that sits there for a really long time, it can have tombstones in it that shadow other data, then the other data can't be dropped, or you can just end up with a whole bunch of like SS tables per read, which slow things down. It also makes backups kind of weird because now you have this like huge file that gets rewritten sometimes, and like now you have to back up like a 1 terabyte SS table. Like it's just kind of ridiculous. So one of the nice advantages into UCS is that it will break up SS tables at predetermined boundaries. And so when you use your scaling parameters and you pass T4 or T8, T8 just means tiered 8. Tiered 8 is like size tiered compaction, but it waits for 8 SS tables of the same size to be grouped together. So basically, when you start doing T and you go higher and higher in the numbers, you end up with something that's more and more friendly for write-heavy workloads, because you're basically delaying compaction until you have 8 tables that are similar in size that can be compacted together. So I think based on what I've seen so far and I've read, my understanding of this, if you have a write-heavy workload, and the reason why I picked random access is because it's not a time series workload. It's actually just accesses random rows within the partition. The reason why I like this is because if you have a write-heavy workload that does do that type of random access, and it isn't going to work well with TWCS, then UCS with a higher T value should allow you to run those workloads, because again, you're going to have low levels of read and write amplification. So let's see. Oops. So if we look here in the documentation, you can see that this is here, right? So basically, it's really, really, really smart design that does a whole bunch of like what I like about it is it's a nuanced, intelligent design that fixes subtle issues that cause each compaction strategy to have like some flaws. So for write-heavy workloads where leveled compaction is not going to be a good fit because of the amount of read and write amplification, UCS looks like it is a no-brainer replacement. Even if you use T4, which is the same setting as size tiered by default,